Okay, now this is our second problem. So this problem I have taken from Kulshritra, the reference text of KTO, one of the reference texts. Okay, now this is the question. A magnetic circuit shown in the figure is made of a wrought iron. Central limb has cross-sectional area of 8 cm square and each side limb has a cross-sectional area of 5 cm square. Calculate required ampere turns of the coil wound on the central limb so as to produce a flux of 1 milliweber in it. Neglect the magnetic leakage and fringing effect. The magnetization of wrought iron is given by the following table. So you have the table where you have the value of B and corresponding B you have the value of H. Okay. Now this is the question. And definitely in the question, as per shown in the figure is mentioned, you have a figure also here. So here this is the case. You have a central limb, you have the side limb, and you have a small air gap. Okay, so no problem. Whatever be the kind of problem that you get, just follow the method. Okay, so what's the first thing? Given data in the standard form. Okay, so we'll first write the given data. Okay, so read the question. Okay, now the central limb has a cross section area of 8 cm square. So that is area of cross section of the central limb I have denoted as AC. 8 cm square, standard form, 8 into 10 raised to minus 4 meter square. Also, each side limb has a cross sectional area of 5 cm square. Definitely. So I have mentioned that area of cross section of the side limb as AS, that is equal to 5 cm square is equal to 5 into 10 raised to minus 4 meter square. Okay, convert to standard unit. Now calculate the total ampere turns, so the total mmf of the coil wound on the central limb so as to produce a flux of 1 milliweber in it. That means central limb ka flux is 1 milliweber. Okay, so flux of the central limb denoted by phi c is equal to 1 into 10 raised to minus 3 Weber. Okay, now after that what we have is nothing but the table where depending on the value of B you have the value of H. Okay, when B is 1, H is 200. When B is 1.25 Tesla, then H is 500. Now see the figure. Definitely search for some data in the figure. Yes, you have the data. The length of the magnetic path ABCD is given as 34 centimeter. Also AFED is also 34 centimeter. Definitely the length of the path GD is given as 15 centimeter. There is an air gap of length 1 millimeter. So write them. That is length of L, AFED and length of ABCD is nothing but 34 into 10 raised to minus 2 meter. Now length of the central limb, that is GD, is nothing but 15 into 10 raised to minus 2 meter, and length of the air gap, that is LAG, is 1 into 10 raised to minus 3 meter. Okay, so I have written down all the given factors. Now what's the next thing? 3 formulas we need to apply. The first 2 formulas come from the parallel concept, that is phi is equal to phi 1 plus phi 2 and also phi 1 s1 is equal to phi 2 s2. So how many phi is given in the question? Only one phi, that is phi through the central limb. Okay, now which is phi 1 and phi 2? Please search for the coil. As per the question, the coil is wound in the central limb. Okay, so this is supposed to be your phi. So phi should be divided into phi 1 and phi 2. Okay. Now phi is equal to phi 1 plus phi 2. So you only know what is phi in the central limb. That is, you know only what is phi. You don't know what is phi 1 and you don't know what is phi 2. So you need to find both. So this formula cannot be used right now. So check further. Go for the next one. Phi 1 s1 is equal to phi 2 s2. Okay. Now write down, reduce s into L by mu 0 mu r a. Okay. So after reducing s into this L by mu 0 mu r a wal equation, I got this mu 0 mu r a s, everything is common, so common factor I just cancelled it. Length of AFED and length of ABCD, as per the question, both are same, so I just cancelled all the common factors. So what I received is nothing but phi 1 is equal to phi 2. Okay, now we'll go for the next formula, that is phi is equal to phi 1 plus phi 2. Then what I receive is phi is nothing but 2 into phi 1. Okay, you know what is phi? then you can find what is phi 1 and phi 2. So since we know the value of phi, or the value of flux in the central limb, you can find the value of flux in the right and left limb. That is nothing but 0.5 into 10 raised to minus 3 Weber. Okay. Now, what's the third formula to be used? The total MMF Wall equation. The total MMF required is equal to MMF of the limb where you can have you have the coil wound plus MMF of any of the other parallel path. Okay, so here here is a place where you have the coil. So the MMF equation is nothing but MMF, total MMF required is equal to MMF of AD plus MMF of ABCD. Now this is the equation I have used. Okay, so MMF of AD plus MMF of ABCD. Total MMF, definitely the formula to be used is nothing but N into I. Okay, but here since in the question we need to find total MMF only, so no need, if you didn't break down also no problem, because as per the question you need to find what is the total MMF. Now HAD into LAD, MMF, the other formula, please write it as H into L, Walla formula. So now consider the path AD. See here, AD path, you have two material. One is the magnetizing material and other is the air gap. So you need to write the H equation for two path as two different equation. Okay, that is MMF of path GD plus MMF of path AG. Is that clear? Okay, so MMF of path GD plus MMF of path AG, then MMF of path ABCD. So AD I have broken down into two, GD and AG. Okay, now we'll see what is MMF of GD path. To find what is MMF of GD path, we need to find what is H of GD. H of GD is equal to, H is equal to B of GD path divided by mu 0 mu r. Now what is B? B is nothing but phi by B of GD, that is central limb. GD is a central limb. B of GD is equal to phi of central limb divided by area of cross section of central limb, that is nothing but 1.25 Tesla. So you got the value of B. How to find the value of H? Just refer the table. As per the table, if B is 1.25, then H is nothing but 500. Okay, so from the table we got H as 500. Now substitute here. We know what is LGD, right? Length of GD path is 15 centimeter. So substitute it to get the first MMF, that is MMF through the path GD. You get 75 ampere turns. This is clear, right? Now go for the next path. First find what is HAG. HAG means B by mu 0 mu r. B can reduce to 5. A mu 0. Air path means mu r is equal to 1. That's why it is 5. Mu 0 mu r 1. Then area of cross section. So substitute everything. You get what is H. Now multiply with the length. So you get what is the MMF in the air path. Okay. The second part. Now the third one, ABCD. Now ABCD length may you need to find what is the MMF. So first HABCD, that is phi by A of the side limb. Then you got 1 Tesla. Refer the table. The table, when B is 1 Tesla, then H is nothing but 200 ampere turns per meter. That is B is 1 Tesla means H is 200. Okay. So refer the table, find H, then multiply with the length. You got the MMF of the path ABCD. So you got MMF of these three paths, equation 1, 2 and 3. So substitute all these three equations in A. Okay, to get the total MMF as 1137.7 ampere turns. Okay, now I hope this is clear for you. So please, while you are doing any problem, try to follow in this method. After writing the given value, go for the parallel concept formula. Okay, the parallel circuit concept formula. Then go for that is a 2 formula, phi is equal to phi 1 plus phi 2 and phi 1 s1 is equal to phi 2 s2. Then the third formula, that is total MMF Walla formula. So when you apply all these three formulas, then whatever be the question, you will be able to solve all the asked data. Okay, so try to follow in this method. Thank you.